Hello friends, I am Professor Aditya Shivaji Bhavani. Today we are going to learn specific speed and unit quantities. So during this session we will be able to illustrate and understand the specific speed and unit quantities, its importance and significance. So definition of specific speed, it is defined as the speed of turbine which is identical in shape, geometrical dimensions, blade angles, gate opening, and which will develop unit power when working under a unit head. So what this term means, particular speed for which there will be the one power, unit power will be generation, and which head has 1 meter. So 1 kilowatt power and 1 meter head. So for that particular specification, what will be these identical dimensions of the particular turbine will be that. We define that term as specific speed. So let us derive the expression for specific speed. Initially what we will go for overall efficiency. What we know for overall efficiency is nothing but shaft power by water power. So shaft power is PS in this case, and water power I can say rho g QH. So from this equation I can derive as PS equal to overall efficiency into rho g QH. So from this equation we can see PS, that is shaft power, is directly proportional to Q into H. So consider this as equation 1. Also we know that U is equal to Ku into under root of 2gh. So U is directly proportional to under root of h. Similarly, V also V equal to Cv into under root of 2gh. Likewise, V is also directly proportional to under root of h. So consider this as equation 2. Next, U equal to pi dn by 60, that we know. From this equation, I can say U is directly proportional to dn, since pi and 60 is constant. So from equation this 2 and 3, what I get, so here U is directly proportional to under root of h and U is directly proportional to d into n. So I can derive it as d into n is directly proportional to under root of h. So which I can say d equal directly proportional to under root of h by n. Next, we have to find discharge. So discharge is equal to area into velocity. So what we know for area is equal to pi by 4 into d square. So what it means, pi by 4 is constant. So d square, velocity we know, velocity is directly proportional to under root of h. So under root of h, so I can say q is directly proportional to d square into under root of h. So the equation becomes q is directly proportional to under root of h by n. So we know d is equal to under root of h by n. So instead of d square, under root of h by n bracket square into under root of h. So what it becomes? So it will become h into h raised to 1 by 2. So it becomes h raised to 3 by 2. So q is directly proportional to h raised to 3 by 2 divided by n square. So n square. Next, we'll substitute this value in this equation. What we get, p is directly proportional to h raised to 3 by 2 divided by n square, that is for q, and this h will remain as it is. So I can say 3 by 2 plus 1 by 1. So I can say 3 plus 2 5, 5 by 2. So p is directly proportional to h raised to 5 by 2 divided by n square. So I am removing this constant of proportionality and taking k as constant of proportionality. So p is equal to k into h raised to 5 by 2 divided by n square. So consider this as equation number 6. So according to our definition, what we are considering, for 1 meter head, the power developed is 1 kilowatt. So speed becomes specific speed. So ns, we are denoting specific speed by n subscript s. So power equal to 1 kilowatt, k will remain as it is, h 1 meter, yeah, for n it is ns square. So what I get, k is equal to n square. Substituting this k is equal to ns square in this equation 6, what I get, p equal to, instead of k, ns square h raised to 5 by 2 by n square. Now rearranging these terms and getting the value of ns equal to p into n square divided by h raised to 5 by 2. So taking square root from this equation, what I get, n square becomes n under root of this term. So from this term what will come outside, instead of n square it will come n under root of p. So here is h raised to 5 by 2, so I am taking h raised to 5 by 4 as common. So what will be the final equation, n is equal to n into under root of p by h raised to 5 by 4. This is very important term. You will be having for derivation as well as numerical based on specific speed. You need to always remember that in this case p is in kilowatt and h in meter. Next is significance of specific speed. So specific speed plays very important role for determining the type of turbine. So also it determines the performance of particular turbine. So if you see this chart, 8.5 meter to 8.5 to 30. So for specific speed this range we will have to use belt and wheel with single jet. For second case 30 to 51, belt and wheel with 2 jets or more than 2 jets, but we know maximum 4 jets can be used, or which is higher efficiency. If you go for 6 jets it will not be more efficient. Next is 51 to 225, which is Francis turbine or medium head turbine, and next is last one 225 to 860, which is Kaplan or propeller turbine. So if you want to learn more about the significance of specific speed, refer Turbo Machines by R.K. Rajput, page number 140. Next term is unit quantities. So whenever we need to find out if we are having single turbine and its specification, and if you want to calculate this similar turbine with different heads or different parameters or different power developed at particular head or different head, in that case unit quantities are important. Let us study one by one. There are 3 quantities. First is unit speed. So it is defined as the speed of turbine working under a unit head, that means h equal to 1. We know in this case u is directly proportional to under root of h, that is u equal to pi dn by 60. From this case I can say that u is directly proportional to n, since in this case diameter is constant. That is important since we are considering the condition for same turbine which is having same pipes, length and diameter, for which the diameter will remain same. So I can say u is directly proportional to n and u is directly proportional to under root of h. So n is directly proportional to under root of h. So therefore n is equal to k1 under root of h1. I am removing this constant of term. So n equal to k1 under root of h. When h becomes 1, what this equation will be, n this normal speed becomes specific speed for unit speed when h becomes 1. So n becomes nu equal to k1 under root of 1. So nu equal to k1. So substituting this nu equal to k1 here, what you get, n equal to n equal to nu into under root of h. So final equation becomes nu equal to n by under root of h. So likewise if you are having multiple speeds and heads, so it will be n1 by h1 equal to n2 by h2. If you are having one quantities, you can find other quantities. Next is discharge, unit discharge. So it is defined as the discharge passing through a turbine which is working under a unit head. If its head is 1 meter, that discharge we can say it as unit discharge. So we know discharge equal to area into velocity. In this case we already mentioned diameter remains same. So Q is directly proportional to velocity, and we know velocity is directly proportional to under root of h. So therefore Q equal or directly proportional to under root of h. Q equal to K2 under root of h. Consider it as question 1. When h equal to 1 meter, discharge becomes unit discharge. So unit discharge equal to K2, h equal to 1. So K2 equal to Qu. Therefore substituting this value in this equation, Q equal to, instead of K2, Qu, what I get? Q equal to Qu under root of h. Final equation becomes unit discharge equal to Q by under root of h will be equal to Q1 by under root of h1 equal to Q2 by under root of h2 likewise. Last one, unit power. It is defined as the power developed by the turbine which is working under a unit head. What it means, whenever there is a 1 meter of head and the power developed by the turbine, and that power developed by the turbine is called as unit power. We know overall efficiency equal to shaft power by water power. So I can say power is equal to overall efficiency into rho g QH. I can say that is shaft power is directly proportional to Q into H. Since V is directly proportional to under root of H and P will be directly proportional to under root of H into H. So as we know Q is directly proportional to velocity. So power is directly proportional to h raised to 3 by 2. That is 1 by 2 plus 1. It will be 3 by 2. So if I am removing this constant sign, so I am taking K3 as constant of proportionality. So P equal to K3 h raised to 3 by 2. Consider this as equation 2. When h equal to 1 meter, P equal to Pu. Whenever h head becomes unit head, power becomes unit power. So unit power equal to K3, h equal to 1 meter, it becomes Pu equal to K3. So substituting this K3 in this equation, K3 value, K3 equal to Pu. So P equal to Pu into h raised to 3 by 2. The final equation becomes Pu equal to P by h raised to 3 by 2. So if you are having multiple power and variable heads, in that case you can rewrite as unit power equal to P1 by h raised to 3 by 2 equal to P2 by h raised to 3 by 2 equal to P3 by h raised to 3 by 2 of 3. So if you have this value, you can calculate other values. So during this session you will able to illustrate the what is specific speed, its importance, and how it is been useful to carry out or select the turbine and unit quantities. Thank you.